Okay, as mentioned, I want to show you one thing I've seen that makes sense building CNNs that has led to good scores. This comes from one of my books I noticed, but I've also seen it with your cohort lead and elsewhere too. Another place to go, by the way, you guys should all try this. Like type stuff in. You know what I mean? Like search in CNN um, MNIST Kaggle competition. And then when you do that, you can like look. I mean, I have a link up here. I've clicked at. You can find like links within Kaggle, and you can find notebooks where people are showing you the code that they did to get like look 99.8%. I mean, hey, right? Interesting. And what you'll find is if you scroll, I would just scroll down to where's the model. Um, and you know, you certainly look at some of the other pieces would be valuable. But here you can see like what they did, right? And they have I've also, this was the other piece I remember, was some people were going up in the number of filters, right? And note we've got two 64s here, two 128s here, and a 256 here. Okay. And we've also something added batch normalization, which is a good idea if you haven't tried it. So I'm seeing more convolutions, more filters. And this is the other piece I want to add in after you flatten it, typically a layer here. Now keep in mind, these are often done with very large data sets. Okay, because we're using a subset. So you got to know how big your data is. Okay, so going back here, like I just want to try the one, right? Like just a regular model dot add another dense layer. And we saw some big ones. I don't know that we need to go that big. Like I think 64 is big. Maybe it's overkill. I'll go 48. I don't know. Just got to try something, right? Feel free to pick your own number here. Add hidden layer. So this is back. See, once you hit the flatten, now it's just like the regular deep learning. You've got like flattened pixels, and you can in effect choose like, well, hey, how many dense layers do you want? Like how many hidden layers? You could have a bunch after this if you want. You don't want to overdo it because the main point is what's actually before it, the convolutions. Um, I think I'm going to cut this down a little too. Okay, so I'm going to try that. Let's see how this does. That's just one step here. And then I think I'm going to look at building up the convolutions too. Now what happened? Oh, I'm sorry because I just changed this notebook. This will not happen for you all. I need to run all. Okay, common error though. All right. Watch that when some of your errors. So I like to leave the errors in because you're going to get them too sometimes, and it's kind of inexplicable. And kind of running off, you have a bunch of stuff is a good idea. And so the only other thing I'm going to try in this mini lesson is I'm going to try changing the convolutions. And maybe I'll take out one of the dilation rates too. So I kind of like this idea too of waiting to do the average pulling. I think that's kind of fun. So like what if I copy this and I just do a straight, I take out the dilation rate, a straight 64. So that's a lot. And I go down to just maybe one straight 32. So when I do that, I'm adding a lot of parameters there. And, you know, I'm just trying something there. Again, along the lines of the types of things that I've seen that have worked. You can see it's getting good accuracy scores, but we don't know yet with the test score until the end. We don't have our validation set here, which we'll clear up in the other lesson. All right, so as that's finishing, the name of the game again here is experimentation and just like using things. Like, I don't think it's okay. Like, here's a question: is it worth copying this code? I mean, like you could, but it's kind of cooler to just look at it and learn from it and try some of the things in it because then it's your own instead of being like, yeah, I got a 99.8% from having copied this person's code. Well, first of all, I don't know that you'll get that like straight out with a smaller data set and without the steps before. So just learn from people and use pieces. You're certainly free to copy code, okay? That's totally fine. All right, so how do we do here? good, 98.7. That's a strong one. All right. Now, big question is, do I leave the dilation? I'm going to leave it in. So I've got, what do I have changed? This big convolutional layer, and this one has the dilation rate out. Okay. So, and that dense 48 layer, did it help? I mean, it's hard to know. I'm just going to leave, maybe I'm going to lower it a little. How are we to see? One thing you can check is how was the accuracy. I mean, it was actually pretty close, right? It wasn't overfitting much. Maybe I'm going to keep it. All right. Last one. And in effect, as we conclude here, I'm going to let it be a mystery. I do want to say that this does give us basically all of the core tools to build CNNs and Keras models. So from here on out, it's going to be a matter of utilizing them to make the best models that we can. Okay. And I think what we're going to find is that, you know, I'll do my best trying to combine things. You guys do your best. Your cohort lead is going to do her best. We're all going to do our best. Don't fixate on the scores, which is hard not to, because a part of it is like, right, we're all learning. And one other piece here to keep in mind is, I know I keep mentioning this, but it's worth it, is that this is deep learning. And when you're doing deep learning, it's designed for big data and small gains. Okay. So once we reach this point, I still think it's worth kind of like trying, if you're going to try new things out, to try it on the subsets, you can try mini. But when you're like on your own, like if I'm on my own here, you know what I'm doing? I'm doing the whole data set and I'm leaving the computer and coming back to see. Okay. And again, this whole data set is actually a subset. Okay, I'm peeking. Oh, this is moving slowly. We're getting good accuracy. Why is it moving slowly? It's because of, well, look here. Look at the total parameters. See, when we add in this second convolution, look what it does to the number of parameters, right? Because it's on the first one. See, and so this is a huge number of parameters to the point where I don't know that I'm going to let it finish for logging off because I kind of don't need to, right? You guys have code. You're going to be running it, right? We're going to have little breaks. So I'm going to stop this lecture here. And what I want people to do, you make your own modifications, you let your own code run, and you share with each other, okay? I want to hear what you all are doing to get the good scores. We're all in community here, so we're all working together. We're all learning from each other, and that is the goal. And try things out with the MNIST dataset too. We've got a cool project where some of these other pieces like padding equals same could actually be helpful. Okay. Keep up the great work.